Hello friends and my dear students, I welcome you all to my channel. I hope you're all well and your studies are also going on well. If you are new to my channel and or not yet subscribed, I will highly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. This video is part of the playlist CBSE Mathematics Class 7 following the textbook of author RS Aggarwal. This is part 3 of the series of video on the chapter Unitary Method. In this video, I will solve the objective questions, that is MCQ, from exercise 9C on the chapter Unitary Method. If you have not watched the previous two parts where I discussed and solved problems from exercise 9A and 9B on the concept of direct variation and indirect variation, then I highly suggest that you please watch those two videos first to get a good understanding of the concepts of two quantities that vary directly or vary inversely. If you are stuck at any problem in solving any problem from exercise 9C, then only you can watch this video to see the solution as a reference. So let's get started with this video. Okay, so I have the question paper. I have the exercise 9C problems on the left hand side, and on the right hand side I will solve the problems. So these are all how many questions are there? There are how many questions are there? This is where is the next view? This is exercise 9C. This is question number 1 to 5, and where is the other question? Sorry friends, exercise, okay. Okay, I will let's first solve the first 5 questions, then I will see the next questions. So the first question says, what is this? Okay, so the first question, let's start solving the problems. The first question says that if 4.5 meter of a uniform rod weighs 17.1 kg, what is the weight of 12 meter of such a rod? So we can clearly see that the quantities for every problem, since all these problems are based on the variation of two quantities A and B, these two quantities A and B, they will vary directly if their ratio remains constant, that is A by B or B by A remains constant, and if these two quantities will vary inversely if their product remains constant. So I will always refer A and B to identify the quantities given in the specific problem. So for this problem, let's say the quantity A represents the length of the rod. Let's say length of the rod, and quantity B, let's say weight of the rod of length A. So we are considering the quantity A as the length of the rod and quantity B as the weight of the rod. Now since the rod is uniform, we clearly know that we clearly understand that the quantity A and B vary directly. That is, if the length is more, the weight will be more, and if the length is less, weight B will be less. So we will have A by B is constant. Now for that is, which means let's say A1 and B1 are two values of these quantities. So the ratio A1 by B1 will be equal to, let's say A2 and B2 are another two values of these two quantities, that is A2 is some length of the rod and B2 is the weight of that length of the rod. Then we will have A1 B1, A1 by B1 equals to A2 by B2. We will use this concept or formula. So it is given that 4.5 meter, this is basically A1. This meter of length of the rod is the weight is 17.1 kg. This we are considering as B1, and it is asking what is the weight of 12 meter of such a rod. Okay, so another value of A, the quantity A, that is the length, is 12 meter, and this is A2, and let's say we will assume that 12 meter of the rod will weigh x kg. So this is B2. So now we know that A1 by B1, A1 by B1 will be A1 by B1, A1, that is 4.5 divided by 17.1 B1 will be equal to A2, that is 12 divided by x. A1 by B1 equals to A2 by B2. From this we have, for this problem, 4.5 divided by 17.1 equals to 12 by x. Now if we solve this for x, we get x equals to 12 into 17.1 divided by 4.5. This kg. So 12 meter of the length of the rod should weigh this amount of kg, and we have to simplify this and see what it is coming to. So this is nothing but 12 into, if we remove the, if we convert the 17.1 and 4.1 into fraction, we get this is 45 kg. Now this is 3, 4 and 3 goes 15, and I guess 3, 5 and 3, 57. So this is okay, so this is 57 multiplied by 4 by 5. This is 28, 228 by 5 kg. This is 4 and 5 point 45.6 kg. So x is 45.6 kg. So the answer is choice C. So if you are while you are watching the solution, you can pause the video and take a screenshot of the solution for your reference. Okay, what happened? Okay, how to insert page. Okay, let's do question number 2. It says in a map 0.8 centimeter represents 8.8 kilometer. Okay, how much distance will be represented by 80.5 centimeter? So over here, let's say the quantity A denotes distance in map, and let's say B denotes actual distance, meaning actual distance, this is in centimeter, and actual distance, this is in kilometer. Okay. So clearly we can see that since we can clearly understand that these quantities A and B, they vary directly. Since if the distance in the map is more, then definitely the actual distance in kilometer will also be more. So they vary directly. So we will have A by B as constant. Now it has given that 0.8 centimeter, this is value A1 for the quantity A, that is distance in map. This distance represents 8.8 kilometer. So this is B1, that is B, the quantity B represents the actual distance in kilometer of the distance A in the map. We have this data. Now it is asking how much distance will be represented by 80.5 centimeter. So 80.5 centimeter, let's say this be A2. Let's say we assume that this will represent x kilometer. This is B2. So now therefore we will have that A1 by A2 will be equal to B1 by B2. This implies for this problem we have 0.8 divided by 8.8 equals 80.5 divided by x. This implies, now x is in kilometer, okay. So this implies x will be equal to 80.5 multiplied by 8.8 divided by 0.8. This is equal to 805 okay. So this is by 10, this is 88 by 10 and whole divided by 8 by 10. We have this. Now this equals 805 into 88 divided by 8 multiplied by 10. Now this is 11 and we have this is 805 into 11 by 10. 805 into 11 by 10, but no, it is not coming. 80.5 centimeter, 0.8 centimeter represents 8.8 kilometer. So 80.5 centimeter will represent, we have assumed x kilometer. So this means we will have A1 by B1 equals to A2 by B2. Sorry, I did wrong. This is wrong. I used wrong formula. It should be A1 by B1 equals to A2 by B2. So the ratio of A by B will be constant. If the two quantities A and B are in direct proportion, then the ratio A by B is constant. Okay. So we have, therefore, since we have A1 by B1 equals to A2 by B2, so this implies for this problem 0.8 divided by 8.8 equals 80.5 divided by x. Now what I am doing, A1 by B1 0.8 by 8.8 equals 80.x. A1 by B1 is constant. Yes. A1 by B1 equals A2 by B2. So 0.8 by 8.8 equals 80.5 by x. Now this implies x equals 80.5 multiplied by 8.8 divided by 85.8. Okay, so this should be the formula. Yes, this is the right. Now if we solve this, so earlier we were doing correctly anyway. So this is 805 multiplied by 88 divided by 8 into 10. Now this is 11, and the value definitely it will come more than. Okay, let's find out what is the value. 805 multiplied by 11, this is 508, and this is 508. So 5588. So 885.8. 885.8 it is coming. This is 885.5, this much kilometer, but in the option we don't have this value. So there is an option D. So I guess, in my opinion, I could be wrong, but the answer is choice D, because the answer is coming to be 885.5 kilometer, and this is not given as a choice. Okay, let's do problem number 3. It says, in a race, Raghu covers 5 kilometer in 20 minutes. How much distance will he cover in 50 minutes? In a race, Raghu covers 5 kilometer in 20 minutes. Now definitely, so the word here, the quantity A, let's say, be distance covered in kilometer, and B the time taken to cover the distance A. So definitely the quantity A and B will vary directly, because if the distance is more, then it will take more time to cover the distance, because Raghu will be running at a uniform speed, even though it is not mentioned in the problem, but we should assume that Raghu will be running at a uniform speed. So more the distance, more the time he will take to cover the distance. So now it is given that 5 kilometer, which is the value A1 of the quantity A, is covered in 20 minutes. This is B1. So it is asking how many distance will be covered in 50 minutes. Let's say X kilometer, this will be A2, is covered in 50 minutes. This is B2. So therefore A1 by, since we know that A1 by B1 will be equal to A2 by B2, since the quantity A and B are they vary directly, that is, the A1 by A by B is a constant. So we will have A1 by B1 equals to A2 by B2. This implies 5 by 20 will be equal to X by 50. This implies X will be equal to 50 into 5 divided by 20. This is 25 by 2, that is 25 by 2. Okay, so this is 12.5. 12.5 kilometer should be the answer. So this is the answer result. So the answer will be choice C. Okay, let's do question number 4. Question number 4 says, a garrison of 500 men had provisions for 24 days. Okay, however, a reinforcement of 300 men arrived. I guess it means 300 more men has arrived. The food will now last for. The food will now last for. So we have already solved similar kind of problems from exercise 9b. So the concept is that it is saying that 500 men, whatever the provisions are, I mean by provisions I mean it is meaning food, whatever the amount of food is available, that food will last 500 men for 24 days. Now however, a reinforcement of 300 men arrived. So now it is asking that if there are 300 more men, then the total number of men is now 800. So how long the 800 men will survive? Now, so this is, we have to consider the quantity, identify the quantity, and we have to understand how they vary. So let's say A be the number of men in the garrison, number of men in garrison, let's say number of men in garrison, and B number of days the men lasts. I mean how many B is the number of days that whatever the provision is, food is, that will help these A number of men to last. If these are the two quantities, then we have to understand how these quantities are varying. They are varying directly or inversely. Now we have to understand that the provision, that is the food, is constant. So if there are more men, definitely if there are more men, then the food will last for less number of days. So definitely it is they are varying inversely. And also if there are less number of men, definitely they will last for more number of days, because the amount of food is fixed. So we understand that A and B varies inversely for this problem. Okay, so now it is saying that 500 men, this is A1, because the quantity A we are assumed to represent the number of men in garrison. So this is one value of A, that is 500 men will last for, whatever food is there will last for 24 days. This is B1. Now it is asking if there are 300 more men, that is now it is 800 men. So this is A2, and it is asking for how long the food will last. So let's say the food will last for X days. So this is B2. Now we know that since the quantity A and B are varying inversely, their product will be same. So we must have A1 B1 equal to A2 B2. This implies 500 into 24 should be equal to 800 into X. This implies X equals 500 multiplied by 24 divided by 100, and this is equals 15. So 15 days. Now that 300 more men has arrived, now it is 800 men. The 800 men will survive for 15 days. So the answer is choice D. Answer is choice D. Okay. Let's do question number 5. It says that if a cistern is filled in 1 minute, if 4/5 of a cistern is filled in 1 minute, how much more time will be required to fill the rest of it? How much more time will be required to fill the rest of it? Okay, so the quantity A can be fraction of cistern, is filled in 1 minute, fraction of cistern filled, and quantity B could be time taken to fill, means time taken to fill the A fraction of a cistern. So the quantity A is the what fraction of the cistern is being filled, and quantity B is the time taken to fill that fraction of the cistern. So clearly we can see that the quantities A and B will vary directly, because if A is more, that is more fraction, that is the more fraction of the cistern, it will take more time, since obviously the cistern is being filled at a constant rate, constant speed. So if A is more, definitely B will, the time taken will be more. So A and B varies directly. For this problem, A and B varies directly, that is A1 by B1 should be equal to A2 by B2. Now the what data is given that 4/5 of a cistern, 4/5 of a cistern is being filled in 1 minute. 1 minute. So this is A1, and this is B1, and it is asking how much more time will be required to fill the rest of it. The rest of it means 1 minus rest of it. Rest means rest will be, since 4/5, rest will be definitely 1 minus 4 by 5. This is 1/5. 1/5 is the rest. 1/5 is the fraction, is the part of the cistern, that is the rest. So if 4/5 of the cistern is already filled, then the remaining fraction of the cistern is 1/5. So 1/5 of the cistern, which is the remaining portion of the cistern, let's say, will be filled in X minute. This is B2. This is B2. So now this implies that according to the formula, A1 by B1 should be constant. A1 by B1 will be equal to A2 by B2. We can have 4 by 5 divided by 1 should be equal to 1 by 5 divided by X. This implies that if we simplify both the left hand side and the right hand side, we get 4 by 5 equals 1 by 5x. This implies 5x equals this implies 5x is 5 by 4. This implies x is 1 by 4. X is 1 by 4. Now 1 by 4 minute. 1 by 4 minute. This amount of minute. Now this is equals 1 by 4 into 60 second. This is how much? This is 15 second. So the remaining portion of the cistern should be filled in 15 seconds. So the answer is choice B. Now I have to see where is the my second where is my second file. browse. Okay. Sorry, friend. Okay. So now I have to increase the. This should be 23. Okay. Let's see question number 6. Okay. So question number 6. It says if 21 cows eat as much as 15 buffaloes, if 21 cows eat as much as 15 buffaloes, how many cows will eat as much as 35 buffaloes? Okay. 21 cows eat as much as 15 buffaloes. Now, so let's say the A is the number of cows and B is the number of buffaloes. Now, definitely one buffalo, every buffalo eats the same amount. Now, if a single buffalo eats same amount, then definitely the more the number of buffaloes, they will eat more. And obviously, if 21 cows eat as much as so if the number of buffaloes is increased, then the amount that is consumed, the food that is being eaten by more number of buffaloes, that same food will be consumed by more number of cows. So in my opinion, I think these two quantity are varies directly. I mean, the quantity A is number of cows and the quantity B is the number of buffaloes, meaning that whatever food is being consumed by B buffaloes, that amount of food is being consumed by A number of cows. So A and B varies directly. So it is very important, it is super important to solve this kind of problem, is to identify the two quantities A and B around which the problem is revolving or the problem is given. And then the second task is to understand whether these two quantities are varying directly or inversely. Only then you will have to apply the appropriate formula, that is the ratio is constant or the product is constant, and solve the problem. So in this problem, I think if we consider A as the number of cows and B as the number of buffaloes, then they will vary directly. So if they vary directly, we must have A1 by B1 equals to A2 by B2. Now the data given is that 21 cows is eating, let's say this is A1, is eating as much as 15 buffaloes, and this is data B1. Now it is asking how many cows will eat as much as 35 buffaloes. Let's say X cows, if we assume X cows, this will be A2, is eating as much as 35 buffaloes, this will be B2. So now we can say that A1 by B1 will be equal to A2 by B2, that is 21 by 15 should be equal to X by 35. This implies that X equals to 21 multiplied by 35 divided by 15. So this is 3 7 3 5 5 7. This is 49. So 49 cows should eat as much as 35 buffaloes. And okay, so the choice is A. The choice is A. Okay. Let's do question number 7. Question number 7 says a tree 6 meter tall casts a 4 meter long shadow. So this is a object and shadow problem. We have done this kind of problem quite a few times in solving 6b and maybe also 6a. So a tree 6 meter long casts a 4 meter long shadow. At the same time, a flagpole casts a 50 meter long shadow. How long is the flagpole? Okay, so we know that A, let's say A, length of object, I mean the object in this case is tree. It could be a tree or it could be a pole or flag or whatever, a building. So length of object, and B, length of shadow casted by the object. Length of the shadow casted by the object. So definitely, if more is the length of the object, then the shadow will be more. And this is so definitely A and B, and this is so A and B varies directly, and for a specific time in the day. So it has given that at the same time. So the ratio of an object and its length, then the length of its shadow that is casted will remain same. This ratio will remain same at a specific time. So at a specific time, you take any object, then the ratio of its length and the ratio of the length of its shadow will be same for any object. But if the time is different, then the ratio will change. But for a specific time, the ratio will be constant. Varies directly. So we have that. See, for the tree, it is saying that for tree 6 meter. So this is, let's say A1. It is casting a shadow of 4 meter. So this is B1. So this data is for the tree, and for the pole, at the same time, a flagpole casts a 50 meter long shadow. How long is the flagpole? So let's say the flagpole is X meter long. So this is A2, and this, for this we have the shadow, the length of shadow is given to be 50 meter. So this is 50 meter. This is B2. So now we will have now, since this A1 by, since these two data quantity A and B vary directly, we must have A1 by B1 equals to A2 by B2. So now from this given data, we must have 6 by 4 should be equal to X by 50. This implies X equals 50 into 6 by 4. This is 2, 2, 2, 3, 2, 25. This is 75 meter. So the flagpole should be 75 meter long, so that it is casting a shadow of 50 meter long. It is casting a 75. It is casting a 50 meter long shadow. So the answer is B. Choice B. Okay. Let's do question number 8. Let's do question number 8, and the question number 8 says that it's a time and work problem. 8 men can finish a piece of work in 40 days. We know that in the time and work problem, the time and the work and the days, number of days and the time, number of men and the number of days to complete the job are inversely proportional, that is the product is constant. So it is given 8 men can finish a piece of work in 40 days if 2 more men join them. If 2 more men join them, the work will be completed in how many days? Okay. So let's say A be the quantity, number of men, and B be the quantity, number of days job is completed, job is done. So definitely we know that A and B varies inversely. Why? Because if there are more men, then they will take less number of days, and if there are less men, then they will take more number of days. So the product is constant, so they varies inversely. This implies that we will have A1 B1 equals to A2 B2. So it is given the first data in the problem. It is given as the first data that 8 men, this is A1, is completing the job in 40 days. This is B1, and it is saying that if 2 more men join them, so the number of men becomes 10 men. Let's say this is A2. The question is how many if 2 men join them, that is in how many days 10 men will complete the job. Let's say that is X days. In X days 10 men will complete the job. So since these two quantities are varying inversely, we will have A1 B1 equals to A2 B2. So this implies 80 into 40 will be equal to 10 into X. This implies X equals 80 into 40 divided by 10, and this is 32. So in 32 days 10 men will complete the job. So the correct choice is B. Okay, let's do question number 9. It says if 16 men can reap a field in 30 days, in how many days will 20 men reap the same field? Okay, it's the same problem. So A is number of men and B is number of days to reap the field. So if we are considering the quantity A to be the number of men and quantity B to be the number of days which is required by the A number of men to reap the field. So clearly we can see that the quantity A and B varies inversely, because the more the number of men, they will take less number of days to reap the same field. Okay, so we see that A, B varies inversely. This implies that A1 B1 will be equal to A2 B2 for two data of the quantity A and B. Now it is given that 16 men this is A1 is reaping the field in 30 days. This is B1, and in how many days will 20 men? So 20 men, this is A2, in how many days? Let's say in X days 20 men will reap the field. This is B2. So therefore we must have A1 B1 equals to A2 B2, that is we must have 16 into 30 equals 20 into x. This implies x equals 60 into 30 divided by 20. So this is 24. 24 is the answer. So the choice is the answer is choice B. The answer is choice B. Okay. Let's solve question number 10. Question number 10 says that 10 pipes of the same diameter can fill a tank in 24 minutes. If two pipes go out of order, how long will the remaining pipe take to fill the tank? 10 pipes of the same diameter, 10 pipes of the same diameter can fill a tank in 24 minutes. Okay. 10 pipes of the same diameter can fill a tank in 24 minutes. If two pipes go out of order, that is the number of pipes now becomes 8 pipes. If two pipes go out of order, how long will the remaining pipe? Oh, if two pipes go out of order, so the remaining pipe means 8 pipes. So basically it is asking that if 10 pipes of the same diameter can fill a tank in 24 minutes, then how long will 8 pipes take to fill the tank? Okay. So the quantities can be A, number of pipes, and B could be time taken to fill the tank. So obviously, since all the pipes are of same diameter, they are filling the tank at a constant rate. So if the number of pipes is more, the time taken will be less. So definitely A, B, the quantity A, B varies inversely. This implies that A1, B1 should be equal to A2, B2 for two given values of the quantity A and B. Now it is given that 10 pipes, so this is A1, 10 pipes takes 24 minutes to fill the tank. So this is B1. It is asking if two pipes go out of order, how long will the remaining pipe take to fill the tank? So the remaining pipe is 8 pipes. Let this be A2, and let assume that 8 pipes takes X minute to fill the tank. So this is B2. So now we must have, since A1 B1 equals to A2 B2, we must have 10 into 24 equals 8 into X. This implies X equals 24 into 10 divided by 8. This is 30 minutes. So 8 pipes should fill the tank in 30 minutes. So the answer is choice C. Let's do, how many problems are there? 14. No, 16 problems are there. Okay. So let's do problem number 11. It says 6 dozen eggs are bought for rupees 108. How much will 132 eggs cost? So this is easy because we know that more the number of eggs, more will be the cost. So A, number of eggs, and B, cost of eggs. So definitely A and B varies directly. This implies that A1 by B1 will be equal to A2 by B2, where A1 B1 is one value of the quantity A1 A and B, and A2 B2 are some other values of the quantity A and B. So now it is saying that 6 dozen, okay, so it says 6 dozen eggs are bought for rupees 108. How much will 132 eggs cost? So now we have to convert the 6 dozen eggs into the number of eggs. So 6 into 12, 1 dozen means 12. It is saying that 6 into 12 eggs is cost rupees 108. So this is A1, this is B1, and now it is asking how much will 132 eggs cost. So 132 eggs, this is A2. Let's say this cost rupees X, so this is B2. Therefore we must have, since A1 by B1 should be equal to A2 by B2, we must have 6 into 12, that is 72. 72 by 108 should be equal to 132 by X. This implies X equals 132 multiplied by 108 divided by 72. Okay. 24 divide 72 with 3 and 24 no 24 6 and 48. Okay, 6 divides 72 with 12 and 6 divides 108 with 18. Now 12 divides 132 with 11. So this is equals to 18 into 11. This is 18 into 18, that is 198. 198. So 198 rupees. So 132 eggs should cost 198 rupees. Okay, so the answer is choice D. Answer is choice D. Okay, let's do question number 12. Question number 12, it says that 12 workers take 4 hours to complete a job. How long would it take 15 workers to complete the job? So quantity A is number of workers, quantity B is time taken to complete a job. Now definitely more is the number of workers, less is the time required to complete the job. So A and B varies inversely. This implies that A1 B1 should be equal to A2 and B2. Now let's see what data is given. It is given that 12 workers, I mean short writing workers as W. This is A1, completes the job in 4 hours. 4 hours. This is B1. Now it is asking how long would it take 15 workers to complete the job. 15 workers. This is A2. Let's say 15 workers takes X hour to complete the job. This is B2. Therefore we have, since A1 B1 equals to A2 B2, we must have 12 into 4 equals 15 into x. This implies x equals 12 into 4 divided by 15. This is 3, 5, 3, 4. This is 16 by 5, 16 by 5 hours. 16 by 5 hours. This is 3 and 1/5 hours. 3 hours and 3 hours plus 1/5 hours. Now this is 3 hours plus 1/5 of hours. Now this is 3 hours plus 1/5 into 60 minute. This is 3 hours plus 12 minute. So 3 hours 12 minutes is the time taken by 15 workers to complete the job. So the answer is choice B. Okay, let's do question number 13. It says a garrison of 500 men had provisions for 27 days. Okay, after 3 days, a reinforcement of 300 men arrived. The remaining food will now last for how many days? We have also solved this kind of problem. This is a little bit tricky problem. So it is saying that whatever the provision is, that is the amount of food is available, that will help, that will last for 77, that will last for 27 days if the number of men is 500. Okay. Now after 3 days, a reinforcement of 300 men arrived. So 300 more men has arrived. The remaining food will now last for how many days? The remaining food will now last for how many days? So after 5 days, after 3 days, we have now 800 men. Okay, and as per the fact that 500 men had provisions for 27 days, after 3 days, those 500 men, after 3 days, whatever food is remaining, in that food 500 men should last for 24 days. So now everything is based on the remaining provisions, remaining food. So let's say A is number of men and B number of days lasted, number of days lasted on remaining food, number of men. So these two quantity are based on the remaining food. So whatever the remaining food is, A is the number of men that will last for B number of days on the remaining food. So these are the two quantities A and B we are referring to. Now as per the problem, we can say that since it is saying 500 men had provisions for 27 days, then after 3 days, as per the problem, 500 men should last for 24 days. So we have this data first. 500 men should last on the remaining food. So after 3 days, whatever the food is remaining, that should last 500 men for 24 days. So 24 days. This is B1. And now we have to find that after 3 days, 300 more men has arrived. So now the number of men becomes 800. Let that be A2, and let whatever the remaining food is remaining, that remaining food is being lasted by 800 men in X days. Let's say X days, B2. Okay, so one more thing is that, so the quantity A and B obviously varies inversely, because the more the number of men, the less the number of days they will last, because the quantity of food is constant. So here the quantity of food means the remaining food. If there are more men, then they will last for less number of days. So the quantity A and B varies inversely. So that means A1 B1 will be equal to A2 B2. So this implies 500 multiplied by 24 should be equal to 800 multiplied by x. This implies x equals 500 multiplied by 24 divided by 800. So this is 15 days. So 800 men on the remaining food will last for 15 days. So the answer is choice A. The answer is choice A. Okay. Let's do question number 14. Question number 14 says that a rope makes 140 rounds of the circumference of a cylinder. A rope makes 140 rounds of the circumference of a cylinder, the radius of whose base, rope makes 140 rounds of the circumference of a cylinder, the radius of whose base is 14 centimeter. Okay, how many times can it go around a cylinder with radius 20 centimeter? Okay, so we have a kind of a cylinder, let's say, sorry for my bad drawing, but anyway, so the base, the radius, this is the radius of the base of the cylinder, and the rope is making rounds. I don't know how to draw, maybe. So the rope is making rounds, this like this. Now if so, definitely a rope makes 140 rounds of the circumference. Now if the base, if the base of the cylinder is more, then definitely the rope will make less number of rounds, because remember here the tricky concept is that the length of the rope is fixed. The length of the rope is fixed. So if the base is 14 centimeter, for a cylinder of base 14 centimeter, the rope is making 140 rounds of the circumference. So if the base changes, then definitely also the number of rounds of the rope will change, because the length of the rope is fixed. So so now the concept is more the base is less the number of rounds. So the quantity A and B we can consider as A as number of rounds of rope, and B as the radius of the base of the cylinder, the radius of the base. So definitely A and B varies inversely. Since the length of the rope is fixed, if the base is more, that rope will make less number of rounds, and if the base is less, the rope will make more number of rounds. So A and B varies inversely. This implies that A1 B1 should be equal to A2 B2, where A1 B1 is one set of data for these two quantity, and A2 B2 is another set of data for this quantity. Now it has given that 140 rounds is being made by the rope when the radius of the base of the cylinder is 14 centimeter. So this is B1 and this is A1, and the next data is that how many times can it go around a cylinder with radius 20 centimeter. Let's say it can go x rounds. When the radius of the cylinder is 20 centimeter, let's say the rope can go rounds x rounds. So this is B2. So now this implies that since A1 B1 should be equal to A2 B2, we must have 140 into 14 equals 20 into x. This implies x equals 140 into 14 divided by 20. This is 98 rounds. So 98 rounds should be the answer. Okay, so the answer is choice C. The answer is choice C. Let's do problem number 15. Problem number 15. It says that a worker makes a toy every 2/3 hour. A worker makes a toy every 2/3 hour. Meaning makes a toy. A worker makes a toy every 2/3 hour. Every 2/3 hour means every 40 minutes. So after every 40 minutes, a worker is making a toy. Okay, if he works for 7 1/3 hours, then how many toys will he make? Then how many toys will he make? A worker makes a toy every 2/3 hour. So basically it is saying that it takes 2/3 hour to make one toy. To make one toy, it takes 2/3 hour. So the question is, if he works for 7 1/3 hours, how many toys will he make? Okay, so let's say A, number of toys made, and let the B be the quantity, time taken to make the toys, that is time taken to make a number of toys. So the quantity A is the number of toys and B is the time taken to make the number of toys. Now obviously if B is more, A will be more, because if the time is more, the number of toys will also increase. If more is the time, the worker will make more toys, and if the time is less, then obviously the worker will make less number of toys. So A, B varies directly. This implies that A1 by B1 should be equal to A2 by B2. Now the data is given is that worker makes one toy, that is one toy. This is A1 is being made in 2/3 hour. 2/3 hour. This is B1. Now it is asking if he works for 7 1/3 hours, then how many toys will he make? Let's say X toys, this is A2, is being made in 7 1/3 hours. This is B2. So this implies now we must have A1 by B1 equals to A2 by B2. So we must have 1 by 2 by 3, it should be equal to X by 7 and 1/3. Now This implies the left hand side becomes 3 by 2, the right hand side becomes x by, if you convert the mixed fraction 7 and 1/3, it becomes 22 by 3, which is nothing but 3x by 22. Now this implies, if you find this is a linear equation, this implies x equals 3 into 22 divided by 2 into 3, 3, 3, 11, this is 11. So x number of toys, the worker should make x number of toys in 7 and 1/3 hours, 11 toys. So the answer is choice D. Okay, let's do question number 16. Question number 16 says that 10 men can finish the construction of a wall in 8 days. 10 men can finish the construction of a wall in 8 days. Okay, how many men are added? How many men are added to finish the work in half a day? Okay, so let A be the quantity, number of men working, and B be the quantity, number of days required to build the wall. Now definitely these two quantity varies inversely, because if more men are working, then less number of days will be required to build the wall. Since the wall is fixed, I mean whatever its length or height is, wall is fixed, so the amount of task need to be done is fixed. So if you engage more men, the time taken will be less. So A and B varies inversely. This implies that A1 B1 should be equal to A2 B2. Now it has given that 10 men can finish the construction of wall in 8 days. So 10 men, this is A1, finishes the wall in 8 days. This is B1. Now it is asking how many men are added. How many men are added to finish the work in half day? So let's say X men are added. If X men are added, we will have 10 plus X men. This is A2, and they are completing in half day, in half days. This is B2. So now we will have that since the quantities are varying inversely, the product A1 B1 should be equal to A2 B2. So this implies that 10 into 8 should be equal to 10 plus X multiplied by half. This implies that 80 equals 10 plus X by 2. Now this is a linear equation in one variable. If you do cross product, we get 10 plus X equals 80 into 2, that is 160. Now this implies X equals 160 minus 10, that is 150. So 150 number of workers has been added such that the total 160 workers is completing the task of building the wall in half days. So the answer is 150. 150 men were added. So the answer is choice D. Answer is choice D. Okay, so this brings to the end of solving the objective question exercise 9C. I hope solving this problem will give you an idea of how to figure out the quantities A and B in a certain problem, and how to figure out whether these two quantities are varying directly or inversely. Accordingly, you have to apply the formula, their product is constant or their ratio is constant, and solve the problem. I hope this video was beneficial. If so, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve the test paper 9, I guess it is 9, test paper 9, which is based on this chapter of unitary methods, that is the two concepts of that is two quantities, are they varying directly or inversely. I will solve the paper tomorrow, so please stay tuned for the tomorrow's video where I will solve the test paper 9. So thanks for watching, and until the next video, take care and bye.